Salam and hello everyone. We from the CSA1 group will present our case study. We will start with question number 1. Causes of stenosis. Stenosis can arise due to atherosclerosis, which is the process that precipitates the coronary artery blockage in the first place. Restenosis also happens due to the response of the vascular tissue to the injury caused by coronary angioplasty. In the case of in-stent restenosis, ISR, it is the result of vascular injury that happened after stenting. The injury caused by insertion of a stent is different from the injury caused by angioplasty alone. In terms of mechanical causes, is under-expansion of the stents. It typically occurs during the process of implantation, where stents are too small or misaligned with inside the blood vessel. It is all from me. I will pass the time now to Alif. Thank you.
Thank you, Siti. Now the next question is how we can overcome the stent restenosis problem. There are 3 ways of treatment that we can take, which is brachytherapy. Brachytherapy is a radiation remedy in stopping every other recurrence of blockage because of scar tissue. Brachytherapy in the artery does not destroy cells within inside the scar tissue that narrows the artery. Instead, a balloon is typically used to open the narrowing as much as possible, after which radiation is used to save cells that cause scar tissue from hastily dividing. Next is reopen the stented area. This is mainly if the original stent becomes too small. The doctors will do a repeat balloon angioplasty, which enlarge the outlet of the blood vessel by pushing back plaque and scar tissue towards the blood vessel wall. These varieties of angioplasty are alternative for surprisingly brief blockage. The last point is plain oil balloon angioplasty, POBA. The technique is quite simple and it will give a positive short-term outcome and minimal risk of complications. Both axial and longitudinal tissue extrusion, as well as subsequent stent expansion, contribute to the initial angiographic improvement after POBA. Patients with a localized pattern of ISR and a stent artery size mismatch detected by intravascular imaging have the best outcomes. When treating patients, a balloon to artery ratio of 1.1 to 1 is often advised for size. So that's all I can share. Now I will pass to Hazira to answer the next question. Thank you.
Thank you, Alif. I will continue this presentation with an answer to question number 3. Based on the table, Biological Evaluation of Medical Device ISO 10993/1, the categorization by nature for body contact for stent restenosis is implant medical device in blood. For your information, the principle of implant medical device in blood is contacting circulating blood in the cardiovascular system. Stent restenosis follows the principle because stent is suitable for patients with obstructive artery disease. Its function to help to flow the blood or other fluids in the artery depending on where it is placed. Next, the contact duration for stent is C-type, which means long-term exposure. Stent are permanent and can last 15 to 20 years. Next, we will go through the biological evolution test. We need to do every single test, which is cytosynthesis, sensitization, irritation, material-mediated phylogeneticity, acute systematic toxicity, subacute toxicity, subchronic toxicity, chronic toxicity, hemocompatibility, genotoxicity, carcinogenic, and implantation. This is all about biological evaluation of the stent. I will pass this presentation to Soin.
Thank you, Hazira. In this question, we will discuss the chemical, morphological, and mechanical properties of our design for coronary stents. The material we choose for making the coronary stent is 316L stainless steel. From the slide, we can see the chemical composition of 316L stainless steel. The maximum carbon content of this material is 0.03%, thereby making this material have an excellent carbon corrosion resistance. The weight percentage range for nickel is 10 to 14%. A high content of nickel can help to decrease ferromagnetic properties by stabilizing the ferromagnetic in a non-magnetic state. In order to reduce corrosion problem, coating is needed. type of coating that can be used are tantalum, which has a highly stable oxide layer that can enhance the corrosion and biocompatibility of the 316L stainless steels, hence reducing the release of the metal ion. Then, titanium nitride oxide. This material makes a bioinner surface and reduces the deposition of platelets and fibrinogen over the stents. Furthermore, silicon carbide has an effect in reducing restenosis by reducing the deposition of blood cells over the stents. Next, heparin is a polysaccharide with negative charge and it is a naturally occurring anticoagulant. Therefore, the formation of clots and the extension of existing clots within the blood can be prevented. That's all from me. I will pass to Husna to describe the other properties. Thank you.
Thank you, So-Yin. Now, I'm going to continue to describe the morphological properties for the design consideration for coronary stent. So, what is morphology? Morphology means the study form comprising the shape, size, and structure. As we all know, the coronary arteries are in a cylindrical tube shape. So, for the shape of our coronary stent, a tube-shaped device has been chosen as the shape for our design. This tube shape will be a great help to supply the blood to the heart smoothly. Then, we have researched the specific and preferable sizing for the stent. So, we have taken in consideration the sizing of our design and summarized it as in the table shown. The design for the coronary stent is woven of wires. This is because the advantage for this design is it has an excellent mechanical support offered to the artery by covering the surface by its braided wires. Last but not least is for the design consideration based on the mechanical properties. We have two mechanical properties that are biocompatibility and biofunctionality. The biocompatibility has the capacity of a medical device as it will be the perfect host response in a selected application. The major characteristic for the biocompatibility is non-carcinogenesis, non-toxicity, and non-allergic response. Then, as for the biofunctionality, it plays a specific role in both physical and mechanical terms perfectly. And that brings us to the end. We sincerely appreciate your interest and time for our sharing today. That's all from me and the rest of our group members. Thank you.